Hey class, Mr. Moydin here with a video on how to approximate a definite integral using a rectangular approximation method. The one I'm going to show you is a right rectangular approximation method, or RRAM you might see. LRAM is very much the same, but for a one minor difference. So here we have an integral, the area under the curve, or the sum from 2 to 5 underneath the square root of x dx, and our number of intervals is 6. So we're getting a fairly accurate, so to speak, because we're using more rectangles than we had done by hand. So let's draw a picture first to get a sense of what's happening. So we have from 2 to 5. The square root function looks like this, right, roughly speaking. This is a general picture, and we're looking for this space. Right? So it's in general a good idea to draw a picture to get you a sense of exactly what it is we're subdividing. The first thing to do is to figure out how wide each of our intervals are so that we can find our endpoints. So delta x is equal to b minus a over n. Let me zoom in a bit so we can see a bit better. B minus a over n, which is the size of the interval divided by the number of subdivisions. So b minus a is 5 minus 2 over 6 rectangles, and then that'll give me 3 over 6, or 1/2. So each interval is 1/2 wide, which allows me to figure out that I'm going to go from 2 to 2.5, to 3, 3.5, to 4, and 4.5 up to 5. So my rectangles would look something like this. So I'd have 1, 2, 3, 4, 5, and 6. They're not quite equally spaced, but you get the idea. Okay, so my first interval is from 2 to 2.5. So there's going to be base times height of each rectangle. And since I'm using the right value, let me zoom in a bit more so we can see the picture. I didn't mean to make it quite as small. Since we're using the right value, then I'm going to use, because of the original question, the right endpoint, between 2 and 2.5, my rectangle is going to go from 2.5. So this is going to be above, in this particular case, 2.5, and there's my rectangle. Likewise, here it'll be from 2.5 and 3. I'm going to use 3. 3.5, 3 and 3.5, I'm going to use 3.5, and so on. So basically, I'll be using all of my y values but for the first one, which is 2. Okay, so that'll help us kind of get a sense of what our sum will look like in total. So the first rectangle is going to have a base of 0.5 by design. So let me actually do this over here. The integral from 2 to 5 of the square root of x dx is approximately the first rectangle, which is base of 0.5. Now remember, they're all going to have the same base, right? 0.5, 0.5, 0.5. So 0.5 times the height plus 0.5 times the height plus 0.5 times the height. Well, I'm going to just factor out all those 0.5s because they're going to sort of distribute anyway. So 0.5 times, well, let's see, my first height in the first interval will be determined by 2.5, so f of 2.5. So that's this length right here, and there's that area when those get multiplied, plus f of 3, that's going to be my second rectangle over here, plus f of 3.5, and I'm going to use all of them up to my last value, 5. Why? Because I'm doing a right rectangular approximation method. So f of 4 plus f of 4.5 plus f of 5. And you'll notice I have 1, 2, 3, 4, 5, 6 heights, all multiplied by the same base width. So when I distribute it, I have 6 rectangles there. Were I doing a left rectangular approximation method, then I would have used f of 2, and then 2.5, 3, 3.5, 4, and 4.5 to get me 6 that way. So this requires a little bit of calculation. So let me show you how to expedite that in the calculator a bit. I'm going to be using a TI-83, but same basic idea. Oops. In my y1, I'm going to enter in the square root of x. I'm going to graph it. Make sure my window is appropriate. If it's not, hit zoom 6. And I'm going to go ahead and find what these values are. You could use a table for this. I like to use trace myself, but really whatever works for you. So trace, let's see, 2.5. The output is, I'm going to go 1.581 plus 3, 1.732, 3.5, 1.871, plus 4, just 2, plus 4.5, which is 2.121, plus finally 5, which is 2.236. So these are my sums of all my heights, or my individual heights rather. So I'm going to add those all up and multiply by the height, the base, which is 1/2. So going back to my home screen, 1.581 plus 1.732 plus 1.871 plus 2 plus 2.121 plus 2.236. So that's that number, 0.5 base times the sum of my heights, 11.541, times 1/2 will give me 5.771. So there, without too much of a sweat, is my approximation for this value. You can also find the exact value. Let me show you how you do that in a calculator. Since I already have it in Y1, what I'm going to do is I'm going to hit trace, second trace, so second calc. Whoops, can't see that. Second calc menu. And if you notice down here, number 7 is an integral of f of x dx. So I'm going to choose that, and it asks for me the lower limit. Well, wouldn't that just be 2? So lower limit is 2. Upper limit is, that's what it's asking for, is 5, if you recall. So from 2 to 5, upper limit 5, 5.567. Okay, so ours was an overestimate, which should make perfect sense. This is an increasing function, and as such, the right value is always going to be higher than the left value. Notice if there were a decreasing function, the right value would be less. So that's how you find a rectangular approximation method. Alrighty, hope this helps.